Welcome to The Explainer. Today, we're going to pull back the curtain on one of the most transformative technologies out there, the Internet of Things. We're going to break it all down, piece by piece, and show you exactly how we give everyday objects a digital voice to build a truly smart world. Okay, let's just jump right in with a pretty big idea. I want you to picture a huge remote forest. Now, what if, instead of finding out about a wildfire after it's already a massive blaze, the forest itself could send out an SOS the very second it started? I know, it sounds like sci-fi, but that's the absolute core promise of the Internet of Things, giving our physical world the ability to actually speak to us. So, how do we even begin to make that happen? Well, the very first step, the absolute foundation for everything else we're going to talk about, is giving every single object, whether it's a tree, a shipping container, you name it, its own unique digital name. And this is where a cool little technology called RFID comes into play. That stands for radio frequency identification. The easiest way to think of it is like a super-powered barcode. But here's the key difference. Instead of needing a laser to see it, it just uses radio waves to shout out its identity. It's kind of perfect for tracking and identifying things on a massive, massive scale. Okay, now this is where it gets really clever. What you're seeing here is how a passive RFID tag works. So the reader on the right sends out a radio wave. That wave hits the tag and, get this, it provides just enough power to wake the tag up. The tag doesn't even have a battery. It uses that little bit of energy to send its unique ID right back to the reader. It's an unbelievably efficient way to give millions of objects a voice. Right, so our object has a name. Maybe it can even sense some data. Now what? Well, it needs a way to talk to the rest of the network. And, just like with human languages, there isn't just one single way for these things to communicate. You've got to pick the right language for the right job. We call these languages communication protocols. And a good way to think about it is like this. Are you going to send a quick, short text message, or do you need to have a long, detailed phone call where you know the other person heard every word? Each protocol is built with different strengths and, some trade-offs in mind. So, one of the most popular protocols, especially because it's so lightweight, is called MQTT. And honestly, the best way to get your head around it is with this awesome analogy. MQTT basically works like a magazine subscription service, but for data. A device doesn't send data directly to another device, it just publishes it. And this image lays it out perfectly. The sensor on the left, that's our MQTT client, sends its data to a central hub, which is called a broker. The broker then acts kind of like a post office, delivering that piece of mail to any other device that has subscribed to that specific topic. The cool part? The original sender has no idea who's listening, which makes the whole system incredibly flexible and easy to scale up. So, the crucial point here is that different protocols are built for different needs. This table's a great example. You've got CoAP, which has a slightly bigger header but uses a protocol that's all about speed. It just sends the data and hopes for the best. Then you have MQTT, with a super tiny header, and it prefers to use TCP, which is all about reliability. It makes sure every single message gets through. It's that classic trade-off, right? Speed versus reliability. So let's recap. We have an object. It has an identity. It has a language. The next piece of our puzzle is the brain, something that can actually process all that sensor data and make smart decisions, sometimes right there on the spot. And in the world of IoT, you've got two main players that usually fill this role. On one side, you have the Arduino. It's a microcontroller, a total specialist. It's amazing at doing one or two simple things over and over again with perfect timing, like, say, just reading a sensor. On the other side, you've got the Raspberry Pi, which is basically a full-blown mini-computer. It's a generalist. It runs a whole operating system and can handle way more complex stuff. And you can really see the Raspberry Pi flex its muscles in a workflow like this one. See, it doesn't just read the data. It can then run a little script to clean that data up, handle any errors, and then format it into a universal standard like JSON. And then, using its built-in Wi-Fi, it can securely shoot that processed info up to the cloud. All of that happens on one tiny board that's the size of a credit card. It's incredible. Okay, so we've put all the fundamental building blocks together. We've got a unique identity, a language to communicate, and a brain to process information. Now, let's see what happens when we actually put them all together to build systems that have a real, tangible impact on our world. Let's talk about air pollution. The traditional monitoring stations are huge, they're expensive, and there are only a few of them in a city. But with IoT, we can roll out these dense networks of small, cheap sensors and get a true street-by-street picture of air quality across an entire city. So, a typical little monitoring node, like the one you see here, combines a bunch of sensors. Maybe one for carbon monoxide, another for tiny particles in the air. It connects them all to a microcontroller, and that node gathers a complete picture of the local air quality, and then boom, sends that data wirelessly for analysis. And the advantages here are just huge. I mean, you get what we call hyper-local data that can show you a pollution problem on a single city block that everyone else was missing. This allows for a real-time response, so officials can get an alert the second that safety levels are breached. And you can even start to combine all that data with wind patterns to pinpoint the exact source of a pollution problem. That's a game changer. And that brings us right back to where we started. Remember that forest that could call for help? Well, using these exact same building blocks, IoT is what makes that a reality. But let's be honest, deploying tech in a forest is one of the toughest challenges you could possibly face. We are talking about massive distances, absolutely no power grid, spotty or just non-existent cell service, and on top of all that, an absolute critical need for the system to work perfectly when it matters most. But this is exactly where IoT shines, because it's uniquely suited to solve every single one of these problems. The sensor nodes use a mix of heat, smoke, and gas detectors for super early and reliable detection. For power, they use small solar panels with battery backup so they can just run on their own. And for communication, they use special protocols like LoRaWAN, which is designed for low-power, long-range transmission. We're talking up to 15 kilometers, which is perfect for sending small critical alert messages from the most remote places on Earth. So from a simple little RFID tag all the way to a life-saving sensor network in the middle of a forest, we've really seen how a smart object gets built from the ground up. This technology is finally giving a voice to all the silent parts of our world. And that leaves us with the final and I think most exciting question of all. What should we ask our world to tell us next?